Today's topic about scaling Twitter with MySQL. And how many of you use Twitter? Raise your hand. Okay, a few. How many of you know the MySQL database? Okay. So we talked about the scaling Twitter with MySQL. Twitter is a successful social network company based in San Francisco. And MySQL is #1 open source database in the world. So first we talked about the basic information about the Twitter data, and then we'll discuss some of the scaling challenges at Twitter. And then the last part, we're more focused on the MySQL side, and since I have been working in MySQL for many years, more talked about what we have done on MySQL development side to make the Twitter scale, to meet the scalability challenges. I heard introduced by myself, so I just talked again. My name is Calvin Sun. I'm the senior manager at Twitter, managing the MySQL development. I have been in the MySQL world for about 8 years. I joined the MySQL managing the storage engines back in January 2006. And then in 2008, I joined Oracle and then managing the InnoDB development team there. And then joined the Twitter in March this year, so it's only 8 months at the Twitter. First about the Twitter. Twitter is essentially is a social network company, and it provides the communication platform for public real-time conversation. According to our CEO, Twitter is the only company on the planet that have the following 4 characteristics. It is a public, real-time, conversational, and distributed. It currently has more than 200 million active users and more than 500 million tweets per day. And Twitter's vision is connecting everyone on the planet. And it's similar to the Escape Planet vision. Escape Planet vision inspiring everyone on the planet. So let's talk about what kind of the data we have with the Twitter. And Twitter started as the simple text, a very short text, less than 140 characters. This is the first tweet by co-founder Jack Dorsey in March 2006. This is the first tweet. And next, there are some more examples about the tweets. And first about the public, it's more about a public announcement. And for example, that Hurricane Sandy happened in New York area, and people doesn't have any information about what kind of service we have, whether the water is safe. So the American Red Cross send information or say, okay, where you can get the food, and New York mayor send out a tweet to say, okay, the water is safe, you can drink the tap water. So that is the kind of the service that Twitter provide for public. And also real-time is when an unexpected event happen and people tweet. It is the first deliver the real-time message. That's faster than TV, than the traditional media. So in this example, this is a pretty famous, one of the airplane landed on the Hudson River, and one of the people on the ferry, they took the picture and the tweet, there's a plane on Hudson River. So that is also conversational, and people, they can express their opinions and discuss certain topic and during the conversation on Twitter, and it distributed basically to everyone there in the world. Here you can see that Twitter has evolved, and from the simple status, simple text message to more conversational and real time, and also embedded images in the tweet. In addition to the text and the pictures, and Twitter also early this year introduced Vine. That's Vine essentially is a small company in New York Twitter acquired early this year. Vine, what is Vine? Vine is it's a 6-second short video You may see 6 seconds is very short, but it can very powerful, can deliver very powerful message or be more creative. This is one of the example. It's pretty funny. You can see they can provide a lot of the things there. So. Another thing, beyond the basic tweets, and we have the social graph. What is social graph? Social graph represents the relationship among the users. For example, I follow you. This is a relationship. And I retweet one of your tweets. Also, I mentioned you in one of the tweets. Those are all the relationships. And so we stored all those relationships in the database to make sure we have the real-time delivery of the information. Here is the diagram is created by one of the Twitter employee. This is a visualization of a tweet mentioned during the 10-minute period time. So in 2011, one day, the 10-minute period, and someone mentioned another one. And this every dot is the Twitter user account, and then as our line as mentioned, if someone will mention another one, they create a line. So this is the entire Twitter universal, and then you can layer down and for each small piece and see what kind of the mention and those kind of information. So this social graph could get very complex. So that's the information we manage in database. Another critical part of the data we manage in Twitter is time series. And when event happen, and for example, in this case, it is a soccer World Cup in 2010. And when you have the goal kicking or have the penalty kick, everything happened, and the influx of tweets were getting very high. So this is the one also typical example. How do we create those? I think the one of the popular is the hashtag. And when you tweet, when you tweet certain things in certain event, you will add the hashtag in your tweet. So in the Twitter analytics side, we will analyze all those information and draw those pictures here. And this is another example. This is this year's President's State of Union address. So here you can see it's this year you have more than 1 million tweets, and then this about the double of the last year tweets. This is all the time series information and what kind of tweets and which time has reached the peak. Here the peak time is they have about 2,400 tweets per minute. So those are the information at the Twitter there. Next about the Twitter scale challenges. Because like all other companies, they deal with big data. They have all the scalability challenges. First challenge is it's just a typical big data problem. And as mentioned, that we have about, right now, about more than 500 million tweets per day. And when Twitter started 2006, it's very, very small. And then in 2009, early 2009, we have about 2 million tweets per day, and that 2009. And 2 years later, in the middle of the 2011, we reached about 200 million tweets per day. So it's a very fast growth. And then August this year, we reached about 500 million tweets per day. So this is a very typical, it's a very typical big data problem. In addition to the large number of tweets per day, we have a very large number of active users. For example, Twitter, we have about more than 230 million active monthly users worldwide. So what that means is that you have a lot of the user follower information and also a lot of the tweets. So this timeline delivery materialization can be very, very slow. And we reach more than 300,000 queries per second for timeline delivery. What is timeline delivery? Timeline, we have about, we have the two, because of Twitter have the time series, we have about 2 timelines. One timeline we call the user timeline. that is one user, all the tweets sent by one user. That's the one user timeline. Another critical, also very challenging timeline we call the home timeline. That's the aggregation all the tweets from all the users you followed. So every time when you log into the Twitter account, you would show the home timeline, you show all the tweets from all the users you followed. So that's actually very, very challenging to deliver that in very short period of time. So we have our system, infrastructure system, have to handle more than 300,000 queries per second for timeline delivery. So you can imagine what kind of challenge they have. And I mentioned the social graph. That's represented the relationship among the Twitter account. And some other social network company has certain limits about how many friends you can have, because, for example, one company have you can maximum about 500 user friends you can have. But that's not the case for Twitter. Twitter, you can have a lot of the followers. And this is the number I took on Monday, just 3 days ago. The top 5 celebrity, they have the top 5 the followers. First one, more than 47 million followers. This is Katy Perry. The second one is Justin Bieber. This is have the more than 46 million tweets. And Justin Bieber has been on top spot for many months, but only this month are talking by the Katy Perry. The third one is Lady Gaga, and the fourth one is President Obama, and the fifth one is Taylor Swift. So those are very, very, very big number in terms of those the followers. And celebrity also is one of the key factors make the Twitter more popular, because the celebrity on Twitter, when they tweet certain things, a lot of the fans and they follow it, so it makes Twitter more and more popular. Another thing is that Twitter not just the number of the followers, also the following. You can follow as many account as you can. This is top 5 the account of the following. This creates a very big challenge, because when Twitter, our system, because we have to really want real-time delivery. So our system is based on the write-based delivery. So when someone tweets, we deliver all the tweet to all his followers. That we call fan out. For example, if the Katy Perry, they send out one tweet, we have to send the tweet information to more than 47 million followers. So that's very, very slow, but that's a synchronized delivery. It's also from infrastructure-wise, it's quite a challenge in there. And another thing is a big challenge is Twitter, as I mentioned, is the real time. And this spike could be very huge. This is one of the biggest spike we had in August this year, and reached 143,000 tweets per second. And average the peak we have about 7,000 tweets per second. But this is the one, when a certain event happens, we can see the big spike. And this is a big spike also create a big challenge into our system, because when you big spike, if you have the expected event, for example, presidential election, New Year, or the sports event, and you could prepare for such a big event. But in some cases, you have the unexpected event happen, you just cannot prepare for it. Those is the big challenge for the infrastructure system, how to handle those big traffic, unexpected event. So to keep the system up all the time is very, very hard. This is the diagram of Twitter website success rate. You can see early days, and because they don't have a lot of traffic, and it's okay. But when Twitter becomes more and more popular, this is mentioned that in the soccer World Cup event in 2010, and Twitter website just temporarily goes down when hit the big spike. And then we had gone through the several re-engineering of the entire infrastructure. And then after all re-engineering, the Twitter website success rate getting very, very high nowadays. So it is big challenges, but it is has gone all those face all the challenges, address those, and make it better and better. Another challenge is agility of scale. What means agility of scale? Because Twitter is a communication platform, but in the meantime, we have more than 50% of the employee engineer, and we have a lot of innovations happen. So we would like to add more services, add more applications to support our users. So we'd like to make it easier. And one of the Twitter culture is that bias to yes. What that means, if you have the good idea and you want to implement it and want to present the idea to a user, and you don't need any approval from the management, from the CEO or from others. We make that very easy, and we have called the decider and system. When you implement the idea, you want to have the experiment to, for example, 1% of the Twitter user. You don't need any approval at the Twitter. You can just, enable 1% of the host, have those features, and then select what kind of feedback. If they're successful, and we'll deploy those features to more and more users. So those is very powerful in terms of it's very interesting to Twitter employee, and everyone comes to good ideas. And if the idea is really delivered to 100 million of the users, and it's very proud of the things to do. So that's the very good culture and a popular culture. So infrastructure-wise, we have to make those very easy to do. And when you add the application workload, we'll be able easy to solve those systems. And in the meantime, the resource level, we make that very easier to add or remove the resource. And when you add a new application, you don't have to go through the all approving process to get the new hardware, get the new resource. So with just the system wide, it's very easy to do it. So those are the main challenges we are having at Twitter. Next, we'll more talked about the MySQL at Twitter. First, let's talk about some architecture evolution at Twitter. And I think that's like the most internet company that started with a two-tier architecture. And the front end is we call the monorail. It is Ruby on Rails. And the back end is a MySQL database. It is a single master and master-slave architecture. It is very easy to set up and very easy to write the application to start with it. So that's the very easiest thing to do. It is the first generation of the Twitter architecture. But when Twitter get more and more users, have the more tweets, you can see it is a big problem. One master just cannot handle. One of the things is that have the more tweets, and the tweet cannot store on the disk on my machine. So what do you need to do? And you have to shard it. So the second is still is monolithic architecture, and then the front end is still monorail and still Ruby on Rails, but it is a lot of improvement and add a lot of application getting faster. And the back end, we shard the database. And we shard the database by the time-based sharding. So what that means, when new tweets come in, you write down the latest database, and then all those old tweets in some other machine that have the older the tweets there. So that's what we call the temporary sharded architecture. In the meantime, add the caching layer and make sure we have the caching, have all the fast delivery, all the low latency requirement there. but this is it is by natural the good architecture at that time. But you can see when Twitter getting more and more popular, this architecture is broken. It doesn't work because one of the things you mentioned is that it's a temporal sharded architecture. That means the traffic not balanced. All the machines, they have the latest tweet get a majority of the traffic. And most of the machines, they have the old tweets, they don't get much traffic there. So that is not really a scalable solution. It is address the storage issue, but it is not address the especially write-oriented scaling. Another problem is that every time when a machine is full, it's because all the tweets is full, and you have to set up the new set of the cluster and to take the new tweets. And we have to set up those new clusters every couple of weeks. So it is, operational-wise, it's pretty complex and also expensive. So we had to do another significant re-engineering in our system-wide. This is from the initial monolithic architecture to distributed architecture. What that means that on the front end, we obey all the layered approach to the front end, and the mid layer we have originally monorail to various services, because the monorail is the one big chunk of it, and then they have the big problem, bottleneck and concurrency, and also ownership. It's very complex. No single one really understands how exactly the system works. And when you add the new service, it becomes very, very complex. So we divide the system to the more than 30 different services there. All different services different based on the approach. And another thing is that from original Ruby on Rails to the JVM-based, JVM Scala, and Scala is very popular. Pretty much all those services written in Scala at Twitter. So certainly the performance-wise, they have a huge performance. And originally, we had probably about 200 to 300 query per second on the Ruby on Rails. After upgrade to the JVM whole service-oriented architecture, we can deliver more than 10,000, even 20,000 query per second. So that's the huge win on the front end. On back end also, we changed from the temporal sharded architecture to evenly sharded, more randomly sharded architecture. Because the temporal sharded architecture, as I mentioned earlier, the load really not evenly distributed. So we have to handle the huge load, we have to randomly shard. And for the tweet, we have the tweet shard, we have divided to about 2,048 shards for tweets. So the shard, every tweet can go to any of those 2,000 shards. So that from workload size is more evenly distributed. But the problem with that is because we have the time series issue. Because you cannot just go on all the 2,000 shards and connect all the time information. So we had to create the secondary index for time series. So we add the secondary index. MySQL side, we also upgrade from original 5.1, MySQL 5.1 to 5.5. And in addition to that, on the hardware side, we upgraded to the more modern hardware without SSD. So we've gone through all the significant upgrade on both front end and the back end to make the Twitter success rate is getting very, very high and be able to handle the workload we have right now. This is a more detailed diagram on the back end, and those are the data service layer. And those, not all of the data services listed here is all the major data services and at the Twitter. For example, T-Bird is all tweets, we store the T-Bird, and the T-Flock, all the time series information and T-Flock, Darkwing, all the user information, and Flock, that's the social graph, and the DM-Bird, the direct messaging. So all of those data messages built on top of those MySQL databases. So we have the thousands MySQL database for the data services. So this architecture is more kind of the architecture principle similar to the NoSQL. And MySQL is only as a building block, and it is just as a basic building block. We have all the data service built on top of the Gizzard. Gizzard is a sharding framework built inside, developed inside of the Twitter. The first principle for scalability is partitioning, replication, and indexing. This is pretty much all the scalability. You cannot avoid the partitioning, replication, and indexing. In here, we means that we use Gizzard for the horizontal partitioning. That's the more arbitrary scale up. So you can have the partitioning to thousands of shards, and then for the scale purpose. And then the Gizzard also handle replication, because we can have the every shard have the number of the replicas that handle fault tolerance and also handle the scaling. Because, for example, one of the shard, if this machine is done, you have the other shard. And also Gizzard framework is flexible, and you could have the very number of the replicas. For example, some of the user, if they have a lot of followers, they could have up to 8 replicas and to handle all this information. Another thing is that our replication here is that it's not a strong consistent, it is eventually consistent. So that's the way to handle scalability there. As I mentioned, we build a separate index because all those tweets, all the information are stored in the local MySQL database, and we cannot use built-in index because all the built-in index and in database is local index. We have to build a global distributed index on top of it. Secondly, do what MySQL is really good at. And MySQL, and as well, InnoDB is the storage engine, is the default storage engine for the MySQL. It is a very popular database, and one of the things is good at that, especially the InnoDB storage engine, is very high performance, efficient, and stable. So stability and reliability are the two key for the InnoDB and MySQL, why it is so popular. And so they have the high throughput and performance, especially after the 5.5 and 5.6, they have getting better and better, and lower latency. And one critical part is it is asset compliant. So it never experienced any data loss when you use the InnoDB and MySQL. So very often I heard people ask, why still use MySQL? And why is NoSQL is getting more and more popular? Why not use NoSQL? And this thing actually have been several attempts, not just the Twitter. Facebook has done the same thing. The people attempt to replace MySQL with a different NoSQL solution, but at the end of it still cannot compete in terms of stability and reliability. So that's why in both Twitter, Facebook, the MySQL, and InnoDB, and still the main storage in those companies. But I'm not saying that the NoSQL is not used. Actually, NoSQL is very, very actively used within Twitter. And Hadoop, we have the very, very large installation of Hadoop installation at Twitter, and we have close to 10,000 installation of the Hadoop, and to handle the batch operation. We also use Cassandra for the high velocity write, but low velocity read, and we also use Blob Store for the pictures. But MySQL is not the solution for everything. So they have some limitation. For example, I mentioned that the MySQL replication cannot scale, especially on write side, you cannot scale the write. In our case, we still use MySQL replication within Twitter, but for the non-critical services. And we have probably about close to 50 MySQL replication cluster, but that's mostly for the small scale data and also for the aggregated data. So, but for the scale data services, we don't use MySQL replication, we use the Gizzard there. And also MySQL does not do well for ID generation because ID generation in the database side, it's also local, and we use a Snowflake. It is a distributed ID generator, and they can generate the ID evenly across the shards. Observability is key. I did not realize that when I work at Oracle. When I work at Oracle, develop database, we more focus on the performance, the scalability, but didn't realize about the monitoring, not of the monitoring stuff. But when I work at Twitter and realize, oh, this is especially the internet company, and you cannot, when something happens in the system, you cannot reproduce it. And you cannot take the system to, hey, let's go back and see what happened there. So you have to log pretty much everything important. In our case, we have logged all the user queries, all the log information, all the I/O information. So pretty much log everything there. So when something happens, you will be able to look at the log and see what happened there, and then hopefully be able to trace down the root cause of the issue. And in addition to those, we also add the lightweight information schema tables for table space and the buffer management. That's all inside of InnoDB. And make sure we understand all those buffer manager works. And make them, and because we connect a lot of information, we just make sure the connection process is cheap and fast. So we make a lot of the improvement inside of the MySQL to make sure we connect everything we want to collect and also make it cheap. Fail fast. This is another principle in a lot of the website internet company, and failure is not an exception, it is a rule. So you need to embrace the failures. And as a matter of fact, you have to sometimes make it things fail faster, not slow. And I mean that is that, for example, in our database, when a certain query come in, and in some of if the application not write the query correctly or consume a lot of resource, they may impact other services. So we add the service side statement timeout. So if any statement in the server for more than 5 seconds, we just have to kill the query to make sure to, and then you can put the retry queue. And when you retry a certain period of time fail, we send the error back to user. So just make sure the overall system is healthy. And in that case, you'll be able to trace which application, which query is not optimized. So we'll be able to have the retried query and also have the priority of the queries. And we have the low priority queue. For some of the query, send a low priority queue, some of them in the high priority queue there. Restart fast. You fail fast, but sometimes the system, you have to restart it and to make sure when system get to the bad state, you have to restart system. In our system, we have every machine, they have the more than 100 gig of RAM as a buffer pool. You can imagine this is when system start, it have all the code cache. And when code cache, you cannot serve the service faster. So what we did is that we have the ability to export and restore the buffer pool information. And those information to export does not mean to export the content of the buffer. We instead export the page number and the data page. So that's the information actually very small number, even 100 gig of the buffer pool, those are information is just a couple of meg information. So that's very faster. When system restart, we'll be able, when system restarted, and we will be able to sort those page number and load those sequentially. So that's reload is getting pretty faster. So, and also we reload those from data file to memory, avoid the memory corruption issue. Another thing is that the hardware evolve very fast, and we need to make sure our database is take advantage of the new hardware. And some of the improvement we have done, first one, the NUMA architecture, because pretty much all those modern machines have the multiple sockets that we call the NUMA architecture. We optimize our system and make sure they have the more evenly stable operation workload. And another thing is SSD. And SSD is getting cheaper and cheaper. So we optimize of the system to use the SSD and to make sure they have the low latency. And also SSD is, because SSD is each cell has a very limited lifespan. So we just need to optimize and make sure the write will be evenly write to all the cells of the SSD to make sure entire SSD lifespan is a better lifespan there. And SSD, even you getting cheaper, but it still is very expensive hardware. In MySQL, because of all the high-end hardware, and it's very important as the data grow very, very fast, it's very important that we need to reduce the space assumption. And our development team look at it in the DB and find out some of the optimization, be able to reduce our space consumption, especially in our case, both trees and T-Flock timeline series is as many and store, not many update there. So we just make sure the space is very efficiently used. And in the past, probably need to be over 1 year, because optimization and the space utilization, we saved more than $30 million on hardware because of the space saving. So it is a pretty big saving there. Another thing, understand queries. I mentioned we have a lot of the statistical information inside of it, but that's more general information. Another side of the thing we have done recently is that have the more application-oriented statistical information. For example, in our Flock, we have the support all different applications. When you add the application, when your database has the workload spike, and sometimes it's very hard to pinpoint exactly that workload from which service. So we trace all the queries with 40 common queries, and we trace all those and then trace back to the application layer. So every time when you have the irregular workload, and we're able to understand, okay, exactly which query generated those workload and from which application. And also when you launch new application, new service, sometimes it's really hard to predict exactly what workload impact you have on the database. When you have those statistical information, you will be able to really understand the impact on the database and be able to address some of the issues, doing some optimization needed. And also doing the capacity planning. And the last thing is that learn from community. MySQL has been around for 30 years, and it is a very active community. And one of the good things is MySQL community is that many people, we pretty much know each other very well. And for example, pretty much all those active developers in the Facebook and the MySQL and the Percona and MariaDB, we all know each other. So we learn from each other, understand what kind of things have done in other companies, for example, in the Facebook, what kind of improvement they have done to improve their system, so we can do the similar thing. Next is currently we are actively working on the MySQL 5.6 migration. So hopefully we'll have the better scalability story, and also we're working on the data compression. And we expect to compress of the data and have the additional lot of the space saving and the hardware. So thank you very much. Hopefully have some time for questions.